Our next topic is the relation between the linear and angular quantities. As you guys all know that we have discussed about in the angular, we discussed about the angular acceleration, angular displacement, angular velocity. So with the help of chart, you will guys understand what is the difference between linear and the angular. As you guys on linear means a body is moving in the linear. Angular means that a body is moving in an angular motion, like in a circular motion, uniform circular motion. Okay, so here we will discuss about the linear, and here we discuss about the angular quantities. Okay, so linear quantities, we are having a linear displacement. Okay, in linear we are also having a linear acceleration or velocity. Okay, as well as the linear acceleration. Okay, so as you guys all know, in the we are having angular quantities as well as you guys all know, the angular displacement, angular velocity, angular, the quantities are same, but there is a difference just between the linear and the angular. If we talk about the linear, so the formula of the linear displacement is s. Okay, if we talk about this angular displacement as a formula, we are having theta. Okay, if we talk about the linear velocity formula, so we are having a linear velocity formula is equal to the change in change in displacement upon, or distance upon change in time. Or if you're talking about the angular, so we are having a omega. We have denoted the angular velocity to the omega. So omega is equal to the change in theta upon change in time, which means change in you can say that the displacement upon change in time. So we are having a linear acceleration, so we are having a formula. We are denoted linear acceleration as this a, just a. And if we talk about this, so we are having a formula and change in velocity upon time. If we talk about the angular acceleration, so we are having a formula alpha, we are denoting, and this is the change in angular velocity upon change in time. Okay, so you can see that we are having a simple relation, that here you can see that we are having a change in distance, but here we are not having any kind of a change in distance, like here you can see that we are having a change in velocity, but here we are having a change in, you can say that, the angular velocity. So there is like no relation in this formula. The change in distance is not coming into this, and in this the change in distance is not coming. Here the change in theta is not coming, so there is like no relation. So if you talk about first relationship between the angular displacement and linear displacement. So as you guys all know, we were having a angular displacement. We found a formula, that is angular displacement is equal to the radius upon theta. So as you guys all know, that in one formula, you can say that the linear displacement is also there, as well as in angular theta is also there. So you can say that in both, you can say that in same formula the both terms are coming. This one, the linear displacement is also there, and angular, you can say the displacement also there. So they are having a same relation, so there is no change to this. So they are having a relation between them. But here you can see that this both, you can say that the quantities are having no similar formula, means the in both there's no like quantities are coming same. So now next relation we are going to discuss here, that is the linear velocity and the angular. So relation between angular and linear velocity. Okay, so we have to change what we have to, like here the, you can see that the linear displacement is there, but here the change, and you can say that the change in angular displacement not there, and here you can see that the change in displacement is there, angular displacement is there, but here in this formula the change in displacement is not there. So they are like different. So for the relation we have to like convert these both. So we can write here, let change in displacement and linear displacement and the not a linear change in this is the linear displacement, this is the angular displacement. So these both will be the change in linear and angular displacement. Okay, so we will use this one formula. Okay, so we can write here that we will use s is equal to r theta. S is equal to the r theta. So here with the help of s we are having a value we have considered, that is the theta, or not theta, change in s, mean that is change in linear displacement, and r we are having theta value, that is the change in the angular displacement. So we can write here change in angular displacement. Okay, so you can see that if change is there, which means that the time is will be also there, so we will divide change in time on both side, so you can write here, I can write here the change in linear displacement upon time is equal to r and angular displacement upon time. So as you guys all know that change in, you can say that the linear displacement upon time is the formula of what, is the formula of the velocity, which is linear. If we talk about this, so this is the formula of the, you can say that angular velocity. Okay, angular velocity. So I can write here, this is a v, this is the v, also this is not a v, this is a w. We are denoting angular velocity as a w in the angular velocity, and in the linear velocity we are considered normal v. So I can write here at the you can send the replacement of v, so on that I can write here v as well as r, and you can see that here we are denoting this as a omega, so we can write here omega. So here you can see that the both are having a same relation likewise. Okay, so this is the final, you can say the relation between the linear and the angular velocity. So we are having a final, you can say that our formula, that is this. Okay, so you can see that these both term are in the one formula, like this one linear velocity as well as the angular velocity, so these both are in the same term. Okay, same formula. So for example, let's consider about, let me tell you guys about the tangent velocity. What does a tangent velocity means? For example, I'm having a wheel here, not a wheel, I'm having a string here and a stone is there. Okay, a stone is having a radius, and it is if the, you can say that if there is a stone attached with the string, so if it break, the centripetal force, what is centripetal force? Centripetal means the toward the attraction between the toward the center, that is called the centripetal force. So this is the centripetal force toward the center of the circle. For example, it breaks, so stone will move upward with the velocity 1. If there is another radius of the stone, if this here the string will, like you can see the break, so the centripetal will got end, and here the velocity will be v2, the stone will move here. If there is the radius of this stone here, so if the stone is here, so the radius of the stone will be here. So if the string is break, so the velocity of a stone will be here, so we can write here v3. Okay, as well as if the radius of a stone is here, so if you can say that the centripetal force got ended and stone will move with the linear velocity just with the v4. Okay, so this is what, this is the direction. Okay, so this is what, this is the tangent velocity. What does it mean? Tangent velocity means that the straight line touching the circle, this is a straight line, this is touching a circle, so we can write here, this is, you can say that, we can say that as a tangent velocity. We can say that as a tangent, because this line is also touching a circle, this line is also touching a circle, so we can say that as a tangent, Okay, and they are moving with what? Linear velocity. So I can say that the tangent velocity is also called the linear velocity. Linear velocity. So I can write a formula here. We are having a formula of the linear and the angular velocity, that is this. So we are having what? We are having a tangent velocity. So we can write here the tangent velocity is equal to the same this radius into omega. Radius into omega. So this is the formula of the tangent velocity. So we are consider that as a position vector because of the arrow. This is a position vector. So the what is the definition of the tangent velocity, which means that the product of the position vector as well as the angular velocity, that is called the tangent velocity. In simple word, you can say that tangent velocity also called a linear velocity, just because the straight line that is touching a circle, that is called a tangent. So we can consider that as a tangent velocity too. So in this video we will discuss about the relation between the linear as well as the relation between the linear velocity as well as the angular velocity, and linear displacement and the angular displacement. In the next video we will discuss about the linear acceleration as well as the angular acceleration.